This is a supplementary advanced math lesson covering textbook lesson 57B in your textbook, periods of sinusoids. And so definitional wise, the book says, so any function that will repeat itself over and over again at a regular interval is called a periodic function. And then the interval at which it repeats is called the period of the function. And so we know from previous lessons when we've plotted the value of the trigonomic functions, the cosine and sine, over the complete arc of a circle, with our reference triangles, we noticed it came up with this sine wave. Okay, and here I have an example of a sine wave, a normal sine wave with a magnitude 1, just the sine of the angle. Okay, and we notice it repeats itself every 360 degrees, which I have indicated here by vertical lines on my simplified graph. Now we'll notice, how do we measure a function, the period of a function, a sinusoidal function? You can take it at two places. You can take it at where it crosses the 0 axis, okay? But the only thing to be careful of there, in one period, it crosses that point 2 times. But this way it's on the way up, this way it's on the way down, okay? So if we were to measure the period of that function, we would have to do it where it crosses 0 on the way up, and also the other point of 0 on the way up. It's more often that we would either take the point of the function where it bottoms out, okay, to the point where it bottoms out. There's less chance for error there. Or you could take the point where it peaks to the point where it peaks. Okay, so a couple different ways to measure the period of a function. And so we notice the textbook goes through, if the variable of the trigonomic function is multiplied by a number, it changes the period of the trigonomic function. Okay, if we are multiplying by the variable, which is theta, the angle theta, by a number, it increases the number of periods for that angle of 360 degrees. Okay, so the period will be less. Okay, we have more repetitions of the sine function when we do that. Okay, here it repeats every 360 degrees. When we multiply the sine function by 3, the variable by 3, we notice it causes 3 repetitions of the sine function within that 360 degrees. The period has now become 120 degrees. Okay, every 120 degrees it repeats. Okay, and likewise, if we multiply the variable by a fraction, in this case 1/2, okay, for every 360 degrees, okay, the trigonomic function has only covered 1/2 of its normal plot. Okay, and so the period has now become 360 degrees times 2, 720 degrees. It is lengthened out. Okay, here it is compressed. Here is our normal sine function. So you can think of it plugging in 360 degrees. Okay, if we plugged in 360 degrees, the variable, the angle, feels 360 degrees. In other words, the variable, the x, thinks it's 360. But what does the sine function feel like? When over here, the sine function feels like it's 3 times that amount. Okay, and that's why it plots 3 curves, 3 repetitions within that 360 degree cycle. Okay, here that 360 degrees, as far as the input goes, as far as theta or x feels, it still feels 360 degrees, The sine function, though, feels only half of that effect, okay? So it only plots half of its normal plot as a sine function, okay? So the period lengthens to 720 degrees. So just keep track. The number inside multiplied by the variable theta will increase the number of repetitions, okay? But it effectively decreases the periodic cycle. The period becomes 1/3 of 360, becomes 120 degrees. It repeats every 120 degrees, okay? When we multiply by a fraction, okay, it lengthens out the number of repetitions. It lessens, because 1/2 is less than 1. It lessens the number of repetitions compared to the original sine function, okay? And it lessens the number of repetitions, but it increases the period. 2 times 360 to 720 degrees it takes now for the sine function to repeat itself. The period has doubled. So just keep that, keep track of that. It's different. The number of repetitions is different than what we define as the period. The period is the interval at which it repeats. Okay, so I hope this helps. Shoot an email or a text message with any questions on your advanced math. So long for now.